Hi there, I'm Dr. Koenig, and this is a third video of part 3 on solving equations with rational numbers. If you haven't seen the previous two videos, I started this three-part series with a video on solving one-step equations that have fractions and decimals within them. That's what rational numbers are. Then I did a follow-up video on two-step equations with rational numbers. In this video, we're diving into how to combine like terms. So it's helpful if you already know how to solve one-step and two-step equations. If you haven't seen those, I'll link them here. I highly suggest checking them out. Otherwise, let's jump in. Before we get into fractions and decimals and some of that more complicated stuff, let's talk about combining like terms with integers, something a little more familiar. Now, we consider things like terms if they have the same variable or the same lack of a variable. In this case, when I'm looking for like terms, I'm looking on either side of the equal sign. So I'll draw the line down the equal sign. If you've seen the prior videos, that's a pretty common thing. Kind of helps us understand the left side of the equation and the right side of the equation, and helps us keep it balanced. Now on the left side, I'm seeing things that I would consider like terms, and that's these two pieces with an x. They're considered like terms because they have the exact same variable. They both have an x. Now, you might be thinking, well, this is a like term with this, and yes, we will end up maneuvering those together, but because we've got an equal sign in between them, we're not going to navigate those just yet. So let's focus on that 3x minus 9x. As we know from our study of integers, 3x minus 9x would leave me with negative 6x. So I bring down this negative 6. I'll also bring down the minus 9, the equal sign, and the 12, just to keep my work nice and tidy. Now, once you've combined like terms, you're really just solving like you would any other equation. So I like to circle the term with my variable. That just kind of reminds me what I'm focused on. That's the thing I need to isolate, is that x. Now I see that outside the circle I've got a minus 9. I need to use my opposite operation and add 9. And whatever I do to one side, I'm going to do to the other side. Now I know on the left-hand side, negative 9 plus 9 is 0, so all that's left there is my negative 6x. On the right-hand side, 12 plus 9 gives me 21. Now one more time, I'm working on isolating that variable so I can see that that is here. I can also see that it is being multiplied by a negative 6, and I know that the opposite operation would be to divide by negative 6 on both sides. Now, on the left-hand side, I know I've got 1x, so I've got x equal to something. The problem is I'm not quite sure what negative 21 over 6 is. So you have a few options at this point. I would suggest simplifying that fraction and leaving it in what we would call improper form. Both the numerator and the denominator divide by 3, which would give me negative 7 halves. You might also choose to change that into a mixed number, in which case we would get negative 3 and 1 half. Either of those is acceptable because they are equivalent fractions. Let's take a look at an example that does include some rational numbers, some fractions, and in the next example we'll take a look at decimals. Now again, I really want to focus on either side of the equal sign and look for like terms on either the left side or the right side. We're not looking to cross sides at this point. I see that I have 3/4 x and 1/2 x. Now, if you think back to your fraction rules, we really cannot add those two fractions unless they have common denominators. I know that I've got 4 and 2, so an easy denominator would be 4. Now, the first fraction already has a denominator of 4. The second one is the one that needs to change. So if I multiply the numerator and the denominator both by the same thing, both by 2's, I'll end up with a denominator of 4. Now I have 3/4 x plus 2/4 x, which I know is 5/4 x. So I'll go back into my equation and I'm going to write 5/4x minus 1/2. I'm bringing everything down to keep my work nice and organized, equal to 3/8. Now that I've combined my like terms, I'm really focused on isolating the variable just like I would in any other equation. As you can see, the first step is that minus 1/2 that I need to move away from the variable. I'm going to use the opposite operation and add 1/2 to both sides. Again, I've got fractions that don't have common denominators, so I'm going to do the same work I did before. My denominators here are 8 and 2, so 8 would be a great denominator to use for this second fraction. In order to do that, I'll need to multiply the top and the bottom, the numerator and the denominator, by 4 to get the 8. That leaves me with 1 3/8 plus 4/8, which of course is 1 7/8. I'll bring down my 5/4 x, and I can see that I only have one step left. In the last video, we talked about how when you've got a number right next to the variable, those are being multiplied. So 5/4 is being multiplied by x. In order to undo multiplication, we divide. But when we're dividing a fraction, it's easiest to multiply by the reciprocal. So that's what I'll do here. The reciprocal of 5/4 is 4/5, and I need to multiply that on both sides. Now on the left-hand side, I'm left with 20/20, which is great. 20/20 is equal to 1, so I've isolated my variable. On the right-hand side, I've got another fraction problem that, once again, I'm going to go off to the side and figure out. Now, 1 7/8 needs to be turned into an improper fraction in order to multiply by 4/5. We do that by taking the whole number, multiplying by the denominator, and then adding the numerator. 1 times 8 is 8, plus 7 gives us 15, and then the denominator stays the same, so 1 7/8 is equal to 15/8. We're multiplying by 4/5, which will give us 60/40. Once I've done that step, I still need to simplify, and I'll see that I get x equal to 3/2. Here we have a problem that involves combining like terms, but we're working with a different rational number, a decimal. The same process stands for decimals as it does for fractions, as it does for whole numbers. We're looking for like terms, and we're looking for them to be on the same side of the equal sign, which is why I've already drawn my line down the equal sign. Now I see two numbers, two values that have an m with them. So I'm going to circle those. The first one is a negative. The second one has a plus sign in front of it. So I'm going to make sure to include the sign that comes before both numbers. That tells me what operation I'm going to do with those values. So I know, and I can see that I'm adding negative 0.4 plus 2.9m, which gives me 2.5m. I'll bring down my plus 12, and I'll bring down my 23. Same process stands. Just like before, we're going to circle the variable, and I see that I need to get rid of that plus 12. I do that by subtracting 12 on both sides, and that leaves me with 11 on the right-hand side and 2.5m on the left-hand side. In order to get 1m, not 2.5m, I need to divide by 2.5 on both sides, and that will leave me with 1m, or m, on the left-hand side. On the right-hand side, I've got some navigating to do. I need to see how many times 2.5 goes into 11. In order to divide those, I find it helpful to remove your decimals by multiplying the numerator and the denominator by 10. As long as you do it to both, it's a legal move. 11 times 10 is 110. 2.5 times 10 is 25. And that's an easier problem to go off to the side and divide. So let's do that. Now, I know that in long division we can be a little intimidated, but let's just take it step by step. 25 does not go into 1. It does not go into 11, but it does go into 110, and it does go in 4 times, which I know is 100. Then I subtract, and I get 10. Now from here, we're supposed to bring something down. We have nothing to bring down, so I'm going to add a decimal and a 0. And now I have a 0 to bring down. I also have a decimal to bring up into my answer. Now again, I'm multiplying 25 to get to 100, so I know that that is 4, which is 100. And when I subtract, I end up with 0, which is a great thing. That means I have finished my long division. So I now know that 11 divided by 2.5, or 110 divided by 25, is 4.4. M equals 4.4. These equations that we've seen are not all that different from the ones we've seen in the prior 2 videos. Here we're focusing on combining like terms. What that does for us is simplifies an equation so that it becomes a 1 or 2 step equation like those that we've seen before. In order to combine like terms, remember that you're really only looking on either the left-hand side or the right-hand side, but you're not combining anything that has to cross over that equal sign. If you've got a like term on the left side as something on the right-hand side, that's something you're going to do as you solve the equation. That's not a combining like term situation. My hope is that this video has helped you to better understand solving equations with rational numbers, especially those, of course, that involve combining like terms. I appreciate you being here, and I'll see you next time.